Thank you, everybody. Here we are looking at another applications of UHPC, and I'm going to be talking about UHPC H-Pulse for a bridge that we did in Ontario, Canada. And Dr. Sri is the lead designer for us. So basically, the presentation is in three parts. I'm going to just go through the project background, then Sri is going to go through all that part, the design equations, and then I will come back for the fabrication and construction. So some introduction of the material that we use, Dura UHPC is a kind of a joint venture between Facca, my company at Windsor, and Dura Malaysia, and it's called Dura Concrete Canada Incorporated. We want to use as much local North American raw material as much as possible, okay? So project background, the Lily River Bridge. It is like, it's a two-lane bridge carrying the Highway 11 traffic, which is part of the Trans-Canada Highway. And they want to replace this existing single-span bridge at the same location. So a detour bridge is required. The bridge owner is Ministry of Transportation of Ontario, and the general contractor is my company, and also we are the precast. Now, here's the bridge plan. You can see the existing and replacement bridge at the bottom there, which is the same location. And so 10 meters away, you have to the north is the detour bridge, and that's the bridge that we're talking about. And to the left is the temporary steel modular bridge, which is not commonly known as the belly bridge. And so that's the cross section. So is it moving? Okay. So the foundation plan, you can see for supporting that detour bridge is on piles, which are 6 of them, H-piles, steel H-piles. So here we show the west abutment, east abutment, and okay. So we are going to, the change proposal is to replace the steel H-pile at the west abutment with UHPC piles. Okay, so, and those piles are 1 in 4 battered in the front and 1 in 10 battered at the back rows. So, and that's where we got involved, Dr. Sri and Dr. Cam Ang from Wyoming State University to get involved with the design. I'm going to pass it to Sri now.
Thank you, Philip. I'll briefly mention what we did in terms of design. The project basically involved designing the piles, just like you will design any driven piles. So I work with Cam Ng, who's a geotechnical faculty member at Wyoming University or University of Wyoming, a former student of mine. So we went through some iterations to figure out what would be a most appropriate way to design this particular pile. So it was designed for the required capacity. The piles are to be fitted with approved driving shoes. I'll give you a little bit of history of how we got there. So in the past, we did design and drive UHPC piles without any shoes, but this particular site had some boulders, and we preferred that we will drive these piles with shoes. Estimated pile length was given as 13.8 to 13.5. That's based on our design. And you can see the factored axial resistance that was required for this particular project. I got into the UHPC pile design back in 2006-07 timeframe because of what we typically experience with regular piles, whether it's a steel or concrete piles. The steel and concrete piles do go through damage during driving. We wanted to see if UHPC is a better solution. Obviously, durability is the other component. So that, along with the unique properties that you probably have learned a lot over the years, attracted me to go and look at UHPC pile as an option for the DOTs. The effort was funded by Iowa Highway Research Board as a high-risk, high-reward type program that Iowa Highway Research Board had at the time. So just like any concrete pile, we started with solid, typical precast concrete pile sections. the cost was pretty expensive. We ended up with a hollow sections. Precast fabricators said we couldn't cast those, at least at the time. Then we shipped gears and started to focus on other alternative shapes. And so we went through these iterations, as you can see. The last two, we felt that it would be easier to do. For the initial investigation, we settled on the last particular section, which we call it a tapered edge shape. These piles were designed and drove into the ground. One of the concerns we had at the time was at the top, you would have less effective pre-stressing and your driving stresses could be high. So very first pile we designed, we had a square section at the top just to eliminate that concern. And subsequent studies confirmed us that the driving stresses right at the tip is actually lower than further down. So eventually we got rid of that. We drove several piles, load tested under horizontal vertical loads. We do have one of the piles actually in an abutment in a project in Iowa. That was our final validation to make sure the piles would be appropriate. If you look back at what we ended up producing is, we took one of the HP10 piles and produced an equivalency, if you like. Obviously, the cross-section area went up. The weight remained the same. This was critical for the pile driver. So we wanted to maintain the similar weight. The stiffness is comparable, as you can see. So with that, the pile driver didn't have to do any modification except figuring out how to hold this pile in place, and they were able to drive. So with the opportunity with this particular project that Facca provided, our goal was to look at bigger sizes. So this is a 12 by 12 or HP12 equivalency, if you like. Most of these piles we have designed with 10 strands, the previous one 10 half inch, and this one has 10.6. We could go up to 13, 14 strands and increase the capacity further if needed. It comes down to how the piles will be cast, and I think Facca came up with a creative way, so that's what we ended up with the final shape, as you can see here. Facca provided this information in terms of the initial transfer stress and the expected 28-day strength, as well as the load I mentioned, and they also required to follow the Canadian code standard, which we met in terms of design. We ran WEEP analysis to make sure that the capacity could be captured, and they followed the protocol to make sure that pile would meet the expectations. So all in all, it was a successful design. I'll pass it back to Philip to give more details.
Thank you. So we look at some environmental impact to convince our client to accept the change proposal. So it's the steel versus UHPC piles. You can see that the the blues are the benchmark for the steel piles, and the white one is just the UHPC piles. So there's an increase of 20% or 18% in the mass, but the embodied energy, the carbon, the CO2 emission, and the global warming potential is very favorable, like for UHPC piles. So, oh man, okay. So they are like a huge reductions. So it's very good environmentally for using the UHPC piles. So the fabrication, we are a CPCI certified plant. So we have a 15 meters pre-stressing base. So that's why we cast our piles to 15 meters to accommodate the 13 meter design, and is MTO, CPCI, and all the engineers are there to witness the casting. So here are just some pictures of it. So then we have tested, we collected 2 sets of specimens, one for the QA lab, which is the lab working for the owner, and then we have our own QC testing by another lab. So it all came in pretty good, and according to the designer requirements. And then we did 4-point bending tests, rapid chloride permeability tests, all very good. So then the only snag here is that none of these UHPC power has been driven at a batter. One of them is one in 4, 1 in 10. So we decided to try it out at our yard before we go out to the actual site to drive it. And you can see here, we drove it using the regular power driving machine for H-Powers. And we have a geotechnical engineer locally come and do the PDA test and giving us the set criteria, all that. So we are ready. We have the test, we have the results. Owners are happy. Let's go drive some powers. So let me see if I get this to work. No sound. What happened? Yeah, it's not doing it. But it's supposed to be a video, but it's not doing it. Sorry, guys. Okay. Now it's too loud. Yeah, we did that in April 2020. We dropped the pulse, but you can see a lot of pulse was sticking out of the ground because instead of driving to 13 meters, which we thought theoretically, we actually ended up what, 7 or 8, 9 meters. So we during construction, we also further did a PDA test. The powers are setting as 8 to 9.35, and instead of 13 meters. So, the PDA shows that there's enough capacity. Okay, so as you know, this is a detour. As I mentioned to you, this is a detour bridge. So it's a temporary bridge for a year. And I was in service for a year while we replaced the existing bridge. So after a year, we decided that we should extract the UHPC powers to see what happened. And yeah, you can see there are 6 powers, but we only can extract 2 based on our very sophisticated method. And the other 4 didn't want to budge, so it's there forever. So anyway, you can see on the left-hand side, the power number 2, the shoes was actually detached. We have 3 different types of shoes, driving shoes, just to test it out. The one was detached, but the rest of the powers are good. The one on the right-hand side, the shoes are still intact. So guess what? The left one, we are not going to use it again, right? So here are some lessons learned. UHPC powers can be driven with conventional power driving equipment. They are slightly heavier than steel power, but it can still be handled conventionally in terms of transportation and hoisting equipment. And pretty well, it's the same techniques as the steel powers, tested. And the UHPC powers have higher capacity. It was like 50 or 60% shorter than the steel powers, to get the same resistance. And UHPC powers have lesser environmental impact. So the time to use UHPC powers is now. Here we are doing some more R&D, the University of Windsor, and then Alabama University, and Dr. Sri is heading up a UHPC powers pool fund study. Here are the acknowledgements. Any questions? So that's the picture here is actually the detour bridge that was in when it's completed. Okay. Thank you.
We have time for some questions. Any questions remote?
Yeah, we have two questions.
Okay,
online.
so let's try from the audience. Any question from the audience? Yes, sir.
How did cost compare?
So that's a good question. So typically for the work that we have done, we compare the cost to steel pile to UHPC piles. UHPC piles, we can cut down the length by about 10, 12 feet. Or if the total length is about 50 to 60 feet, that's what we've done conservatively. Plus we do gain in-bearing that steel pile doesn't provide. The in-bearing component, we don't have a good handle on because that's what the pool fund that Philip mentioned is to collect more data so we can come up with the new resistance factors for UHPC piles. If you take data that we have collected so far and compare the UHPC pile to steel pile, the resist, the 100 kips of load, the costs are pretty comparable. So my hope is that we get better if we can get more refined resistance factors.
Question from the,
So we had a similar question online about cost, but what prompted the change from UHPC to steel? Primarily research interest or from steel to UHPC?
yes, reverse, from steel to UHPC.
That's right. I think we probably have different answers. I'll let you talk. So the reason we looked at it is more on the environmental, like rivers and things like that. IOD had some problem with steel piles. It's customary for them to use steel piles rather than concrete piles. So they were looking for an alternative, and so we came up with the idea this would be a better option for them.
My answer is that if you look at the per meter length of a house, obviously UHPC is going to be more attractive. In this case here is really for us to it's a first project, like we want to try it out. It's not to that's the thing. Like even it's a change proposal. When you build a project, it's always paid. The powers are always paid by per foot or per meter. I don't know how you guys do it, but so in fact, we did not get paid as much, right? Because it's only 9 meters instead of 13 meters. So that's the thing. Okay.
Thank you very much for the presentation and the answer to the questions. Thanks again.